So, hello everyone. Thank you for joining us tonight. So, welcome to the Sustaining Our Shores Honours Colloquium. I'm very happy to welcome you to the University of Rhode Island on this fairly chilly November night. My name is Andrew Davis. I'm a co-lead organizer of the colloquium with JP Walsh, who you've seen for the last several weeks. So I'm a new face, so hopefully we'll inspire some new engagement with the program. I'm a faculty member of the Department of Biological Sciences at URI, and I specialize in the study of the oceans and the organisms within. So I come from a biological background, whereas JP's come from a geological background. The colloquium focuses on our shores and our seas because we live in the ocean state. We're surrounded by an amazing coastal resource that presents both significant challenges and unprecedented opportunity. With COP26 just concluding and the United Nations Decade of Ocean Science for Sustainable Development just beginning, the world's eyes are starting to turn onto our oceans and to our coasts. With URI's great expertise in coastal ocean science and management, we have the ability to educate and to help address the issues surrounding our coastal system. And we want to continue to give back and advance our understanding of our local resource. A committee of faculty and staff has planned and executed the Sustaining Our Shores Honours Colloquium to educate and encourage discussion and collaboration around central coastal issues and challenges that we face, starting from the coasting crisis theme of sea level rise through to the future of seafood and sustaining our food security. We turn our eyes today onto the issue of plastic pollution, the growing issue that faces the natural system. I want to thank everyone involved in organizing the symposium and the colloquium. Faculty, committee, and staff have all contributed towards this. And Lynn, Anna, and Deb from the honors team have been absolutely pivotal to ensuring the success of this colloquium this semester. So thank you everyone for your commitment and energy for that process. So before getting into tonight's program, I thank you for attending in person. I also thank everybody online, wherever you are, for joining us tonight. For those of you here in person tonight, please remain with your mask on appropriately throughout the session. Also, please note that the fire exits down the sides, you can see the fire exit signs if the fire alarm does go off. The restrooms are located downstairs or in the foyer just ahead where we came in. Also, I just want to make you aware that next week we do not have a Tuesday evening session because it's Thanksgiving week. November 30th, as illustrated on the side, will be our next event on Tuesday at 7 p.m. And it's going to be an invited panel of experts talking about local to regional issues regarding plastic pollution in New England and Rhode Island. Now I would like to introduce Endoni Spears to offer a land acknowledgement. Endoni Spears received her Bachelor of Arts degree in anthropology from the University of Denver and has worked for the Heard Museum, Museum of Northern Arizona, Mashantucket Pequot Museum, and Research Center. Endoni was a Peabody Essex Museum Native American Arts and Culture Fellow and currently serves on the board of the Federation of States Humanities Council. Endoni is also the co-director of the Upstander Academy and a founding member of the Acamalt Educational Initiative, an indigenous education and interpretive consultancy for museums, K-12 schools, and colleges and universities. So thank you, Endoni, for joining us tonight, and please join me in welcoming Endoni to the stage. Thank you.
Endoni Spears initiate. Hashkan Hatsahonishle, Ojibwe people, Bashashin, Tanasani Dishiche, do Choctaw and Chickasaw people additionally. Hi everyone, I'm Endoni Spears, and I'm yucca fruit strung out in a line clan from the Diné or Navajo people. I'm born for the White Earth Ojibwe people of Minnesota. My maternal grandfather is from the Tangled clan, and my paternal grandfather is from the Choctaw and Chickasaw people in Oklahoma. I am honored to begin our time together by acknowledging that we are gathered in the homelands of the Narragansett people, which is my husband and my 4 children's people. These are the matrilineal Algonquin-speaking people whose cultures, languages, cosmologies, and kinship systems, their epistemologies, were created here, in this land, on these estuaries, rivers, and bays. Their name in their own language for themselves, the Nahaganzik, the people of the small point of land, ties their identity to where the land meets the water, the peninsulas where their origin stories begin. I am here to provide a land acknowledgement. It is important to note that when we use the word in English for quote unquote land, that we have a shared understanding of what I am speaking about. Anytime we use the English language to describe this landscape where URI is located, we are using a foreign language. English has only been here for 400 years. It is a new and foreign language to this place. Our indigenous languages were born here. For 11,000 years, the Narragansett language has been spoken here in prayer and in ceremony, used to negotiate diplomatic ties and create intricate systems of governance, used to make jokes, tell scary and beautiful stories, used to name every member of the plant and animal relatives that share this space. It is the only language that can properly describe this place. So when I say land in the English language, I am not referring to a commodified tract of parceled space depicted in 2-dimensional maps with geopolitical borders carving out ownership like cuts of meat on a cow or a pig. I am not referring to a space that exists purely for extraction and maltreatment. No, when I use the inadequate term land, I am referring to our collective living mother that holds us and gives to us in all seasons. She is generous to all living beings, and she gave us our relationships to one another, our human and non-human kin, and our relationships to God. Our relationship to her situates us within a sacred space between our ancestors and our great-great-grandchildren. When I say the word land, I mean the living container. She contains the molecules of our ancestors that feed our plant and animal relatives today. She contains our medicines that sustain our spiritual health and the foods that sustain our physical health. She is the source of our material culture and thus our understanding of aesthetic beauty. The rhythms and patterns of her own language model for us peace and joy. When I use the term land, I really mean Ake in the Narragansett language, or in my language, Dineta, the motherland. Throughout this colloquium, you have learned from leaders in ecological sustainability who are fighting to change the way humans interact with land and water. If you recognize the science and measures presented here, it is also your responsibility to recognize indigenous traditional ecological knowledge, or ITEK. ITEK is a body of observations, oral and written knowledge, practices, and beliefs that promotes environmental sustainability and the responsible stewardship of natural resources through relationships between humans and environmental systems. It is applied to phenomena across biological, physical, cultural, and spiritual systems. These concepts have been confirmed by the White House Office of Science and Technology Policy and the White House Council on Environmental Quality in a memorandum released during the Tribal Nations Summit held yesterday and today. Reaffirming what our ancestors have known for thousands of generations does not undo what violence has been inflicted on this land via settler colonialism. However, it is an integral first step on our collective journey to a regenerative future for the 1,000 generations to come. Ahehe, and thank you for your time and your continued commitment to learning and unlearning through this urgently important course of study.
So thank you very much, Adonis, for that very, very nice speech. And how you said about how human lives are entwined with the ecology of the natural system. Tonight, there's no better subject to talk about than microplastics and plastic pollution. So today, we're really talking about a global challenge that's impacting multiple people around the world. The issue of plastics in our natural environment. Plastics are one of the most ubiquitous materials in the modern life. We touch plastics every single day in some shape or form. Some of you are touching plastics right now if you're looking at your phone. Okay? It's a ubiquitous material of the modern economy. It's highly important to us, but it also represents challenges as well. There's an increasing body of research, some of which has been done by our invited speaker tonight, that shows that plastics are ubiquitous around the Earth. We're finding them in almost every habitat that we study. Our local waters within Rhode Island are no different. Teams of researchers from URI are also finding plastics in the natural system. J.P. Walsh is working on sediment. My group, with my colleagues, Colleen Suckling, are working on plastics in the water. It is a truly global challenge that requires truly global, international, and national collaboration. URI has recently launched the Plastics Land to Sea initiative. It's a dynamic research network within URI to bring people together to tackle the challenge of plastic, to improve our communication, our collaboration, and research ideas, accelerate how we inform the government around our area to improve policy regarding plastic pollution. So keep your eye on the website for Plastics Land to Sea. There's a lot of research being done at URI that's really going to bring this to the forefront. So now, I have the pleasure of introducing our speaker for tonight, Dr. Chelsea Rochman, an international expert on marine plastics and the associated impacts that they have on the natural environment. Dr. Rochman's group has also been communicating these findings beyond academia to local governments and to nonprofit agencies to educate and inform those avenues. Dr. Rochman is joining us today from the Department of Ecology and Evolutionary Biology at the University of Toronto. Dr. Rochman received her PhD in a joint program with San Diego State University and University of California, Davis in ecology. Prior to joining the faculty at the University of Toronto, Dr. Rochman was a David H. Smith postdoctoral fellow at the Aquatic Health Program at the University of California, Davis. Dr. Rochman is also a scientific advisor to the Ocean Conservancy and the National Geographic Explorer. So please join me in welcoming Dr. Rochman to the University of Rhode Island and the Falls Honor Colloquium. Thank you very much. Please join me today.
Thank you.
Thank you very much.
Thank you. Can everyone hear me okay with the mic that I'm wearing? Okay, amazing. All right, well, thank you so much for the introduction. Thank you for having me here. Thank you for inviting me. It's nice to be somewhere in person, get to see faces, have nice chats, and get to know what everyone here is doing. So I was really thrilled to be able to come, and I'm thrilled to be able to talk a little bit about the issue of plastic pollution. So I'm going to talk a bit about kind of the story of this issue, both from the science side as well as the policy side, and I'll talk a bit about my own work as well. So I'd like to start, before I kind of dive into the history of this field, I want to spend a minute just to kind of focus on the present. So just for fun, before, I think yesterday, I just Googled plastic and looked in Google News to see what are people talking about today. And the thing I noticed is that I feel like plastic pollution these days is in the news almost every day. So what came up in the news yesterday, I found some news about people GPS tagging bottles to try to understand the movement of plastic around the world, and then of course some work about COVID-19 and the amount of plastic waste that's increased with COVID. But what I want to do now is actually dive into the past and kind of think about how did we get here? How did we get to a time where we were talking about plastic in the news basically every day? So over the last 5 decades, the evidence about plastic pollution has been increasing and growing over time. And so I'm going to kind of go through each decade, talk about what we learned, talk about what I think were some of kind of the key moments within that decade informing the field. But of course, I will miss something or maybe choose something different than others would have. But I want to start with 50 years ago with Ed Carpenter's work that was actually published in the journal Science. So about 50 years ago, Ed Carpenter found microplastics, small pieces of plastic in the ocean in the Atlantic, and he found them in fish, and he also found them in water. He published this work in Science, but it didn't really spark a new field, and he didn't actually continue doing this work. He's currently an emeritus professor at San Francisco State University. Then, similarly, as early as the 1980s, the Sea Education Association started monitoring plastics in the oceans. What they would do is they would take undergrads out to sea. They continue to do this. They take undergraduates out to sea, and they're on a research vessel learning all about the ocean. They have different scientific projects, some of which are throwing nets over the side of the ocean to quantify plankton. They started finding microplastic in their nets and decided this was going to be a project that students would take on. Unbeknownst to them, they were building the longest monitoring program for microplastic that we have to this day in the ocean. It's been really informative in the science, and actually a lot of this has been led by Dr. Kara Lavender Law, who will be on your panel. She's a good friend of mine in a couple weeks, so I would encourage you to come to that. And then we have Captain Charles Moore, who was just a man who sailed around the ocean, had enough money to do so, and came across what he termed the Great Pacific Garbage Patch. So he brought to life this idea that there was a swirling island of plastic twice the size of Texas floating around in the middle of the Pacific Ocean. We know it today to look a little bit different than this, and I'll come back to that in a minute, but he really, I think, sparked a lot of interest in this topic. And then in the 2000s, really started to grow this field of microplastics with Dr. Richard Thompson, who really, I think, is probably responsible for helping start this field. He coined the term microplastics in the journal Science in 2004. And remember that those first papers were published in 1970s. I think with this, it really did spark a field of microplastics, sort of separating out those of us that study the big stuff from those of us that study the small stuff, although there are some of us that do both. And then in the 2010s, it became really busy, and a lot of researchers started to come on scene. This was truly recognized as a scientific research field. And you can see that the amount of papers each decade on both the macro and the microplastics really started to increase in that decade. And if I showed you from 2020 on, you'll see there's also a big flurry of research activity. So I want to talk a bit about what we've learned within this decade and what we're starting to learn in the decade that we're in right now. But first, I want to tell a little bit of story about what brought me into this field. So just a little of my history. So for me, it all started actually with the garbage patch. When I was in undergrad, I came across this article written by Ken Weiss in 2006. So about 10 years after Captain Charles Moore discovered the garbage patch. This article won a Pulitzer Prize in the LA Times, describing the garbage patch to the world. And it got me really interested in it in graduate school. And I thought, wow, I've always been interested in waste. I grew up in Tucson, Arizona, so nowhere near the ocean, but I love the ocean. And I wanted to understand more. So after seeing this article, Googling a little bit more about the issue, I decided I wanted to go to graduate school, and I wanted to work on plastic pollution. Now, at this time, in 2006, there weren't a ton of professors that were working on the topic. And it was actually hard for me to find a research advisor who was interested in doing something a little bit outside their field. But I got lucky, and I had a professor, Dr. Brian Henschel at San Diego State, that said, well, I don't work on this, and he still doesn't to this day. But he said, you seem passionate enough, I'll take you on, and let's see what we can learn. So I started graduate school at San Diego State in 2007 or 2008, but I had gone to UC San Diego in undergrad and worked a bit at the Scripps Institution of Oceanography. And in 2008, Dr. Marcus Erickson, who used to work with Captain Charles Moore, but now works for 5 Gyres, came to Scripps to talk about his work in the Great Pacific Garbage Patch. And there were some researchers at Scripps that thought, well, this can't really be an issue. We've gone out on research cruises forever. We used to throw our plastic overboard. We don't see plastic out to sea. But the grad students got really interested. And so Miriam Goldstein, who you see a picture of here, was a grad student at Scripps at the time. And she and a couple of her friends in graduate school or colleagues put together a grant to fund a student-led cruise. And they got the funding, but it only funds about a week of work, and they wanted to get all the way to the garbage patch, was quite a bit further. So Doug Woodring, the other person pictured here, was a wealthy man also interested in the issue and donated hundreds of thousands of dollars to fund the first research expedition out to the Great Pacific Garbage Patch. And with that funding, Miriam was able to run a program that could go all the way into the garbage patch and come back into Oregon. So because I had worked in Lisa Levin's lab at Scripps during that time, and I kept talking to her about this interest in plastic pollution, she said, Miriam, you have to take this girl. If she doesn't get to go, she's never gonna forgive me. She's just down the street at San Diego State. And so in 2009 in the summer, I got to jump aboard the New Horizon, or the first, people had been to the Great Pacific Garbage Patch, but it was the first time a research vessel was really going there. So I hopped aboard the boat, and I was very excited, or the ship, and everybody there was pretty excited, but everyone was also going to work on their normal research projects because they weren't really working on microplastic, and they weren't sure what they were going to find. So every day on the ship, people were sampling for their other samples, but we were throwing a net over every 4 hours to see if we could find microplastic, and people on the bow of the ship were looking for the big stuff at the same time as they were quantifying birds and marine mammals. We weren't really finding anything. A week had gone by. We were starting to get antsy. We were playing with big dead squid that we would find floating in the water. We were looking at bioluminescence and beautiful starry nights. And then one morning I was sitting at the galley of the ship and I'm having breakfast, and all of a sudden the people on the bow who are counting the whales and the birds call us all up there and say, we need help immediately. And we get up there, and what they were doing is they had kind of this ruler off the bow of the ship, and they were told, count the microplastic, or count any plastic as it goes by. So we all go running up to the bow of the ship, and we're looking over the side. And what we don't see is a garbage patch. It's a beautiful, calm day, and what it looks like is something like this. You might see, if this were the ocean, a big buoy over there, and maybe a drink rack over here, and a net over here. But as far as the eye could see, floating on the surface of the water, was like this little confetti, smaller than the size of a pencil eraser, everywhere. And everyone just stood there. And Doug Woodring, who was interested in going out there, he wanted to pay for it because he wanted to clean it up, realized, I can't come out here and scoop this up. And all of us researchers that were interested in ecology and the organisms thought, wow, this small stuff can really get into the body of almost every single organism. And so we became really interested in this. And as we got back to land and actually quantified all of those samples we had put overboard before we thought we saw any plastic, we realized that there was actually plastic in every single sample, or almost every sample, but the majority of it was less than 100 millimeters in size. And so what we had actually found, as I said earlier, is plastic everywhere, but of course more concentrated in that area where we could visibly see it. And we've learned a lot since then, right? The garbage patch is not an island of plastic that we can scoop up. It's more of a dilute soup of microplastics. However, it's also not the North Pacific garbage patch. Plastic accumulates everywhere these currents come together. There's many different garbage patches. And although most of that plastic by weight are these big items like fishing debris and consumer products, most of it is microplastic. And microplastic is an incredibly diverse contaminant that's made up of many different types of plastics. It has many different types of additives associated with it. It comes in many different shapes and colors. And it also accumulates contaminants once it's already in the water. And it's not just about the oceans. I think one of the things that really strikes me today is what we've now come to understand about these contaminants. The field of microplastics, or plastic pollution in general, really started in the ocean. But today there's a lot of work being done in freshwater and a lot of work being done in terrestrial ecosystems. And for microplastic materials, we know now it cycles in the water cycle, it cycles in the global dust cycle, it's in the dust in our houses, and it moves through the food web. So it's really start to kind of infiltrate some of these planetary cycles we know about. So now I kind of want to take a step back and say, when we think about this body of literature that we've created, or maybe this is a step forward, what have we learned? What do we know now about this material that's quite different from 10 years ago when we were interested in starting to know more? Well, there's no doubt anymore that plastic pollution contaminates the global ecosystem, as I just said. We find it in the Arctic, we find it near the equator, we find it in the deep sea. We find it in almost every ecosystem we look in, including where I live in the Great Lakes, which are managed under ocean by both NOAA and Department of Fisheries and Oceans. We also find it in a lot of animals. And this is actually pretty old statistics, both of these, but these are reporting how much plastic in general, how many species have been found with plastic in general, and how many for just microplastics. But these numbers are wrong. As people start to look at more and more species, they find more and more animals interacting with it. And they get to the environment from many different sources. And so the sources can be the different types of litter that enter the environment, like tires, consumer products like some of the single-use plastic items, primary production pellets that eventually make the plastic, fishing debris. But then they enter the water, enter the environment through many different pathways. And I think some of these pathways, like wastewater treatment plant and atmospheric deposition, we're just starting to learn more about. But mostly what we've been talking about over the years is this idea of mismanaged waste. So some of you may be familiar with this statistic. Jenna Jambeck in Science in 2015 worked with colleagues to try to figure out how much plastic waste enters the oceans every year. And the number they came up with was 8 million. And so this number, 8 million metric tons of plastic that enters the ocean, became the statistic of the year that year, and I think really brought this issue to the global stage. So I think the garbage patch sort of introduced this idea to a certain amount of people, certainly brought some scientists on board, and this statistic, I think, really motivated policy change and some of the policies we're starting to see today. But it doesn't include some of the sources of the microplastics. And actually today, when I was having a discussion with the students in the honors course, somebody asked, well, what about policies for microplastics? Are those starting to be enacted as well? And I think now they are, as we start to learn that microplastics also come from paints on buildings and roads and boats and ships, from microbeads in our personal care products, from those pre-production pellets that make plastics, as well as from tires as we drive and clothes as we wash them and wear them. And I think for me, some of the questions I'm really interested in is what happens once they get into our ecosystem? What happens when they get into the Arctic, or they get into the deep sea, or they get into a freshwater lake? Where do they go? Who do they interact with? And do they transform or change? And this takes a lot of methods. So I'm not going to talk about the work that I do in my lab in order to quantify microplastics. But I just want to say that when I got into this field, I did not want to become a methods researcher. And there are people who think of me as someone who builds methods. Because the reality is that there weren't a lot of methods out there for quantifying the really small stuff. And so we've built libraries for microplastics on FTIR and Raman. We've tried to create faster ways for quantifying and characterizing microplastics, which is quite painful. It's literally a lot of students sitting under a microscope counting, and for those of you that are in here that do it, I see heads nodding. It takes a lot of time, so we work with people who can maybe create machine learning algorithms to speed some of that up on the counting and the characterization, and then these libraries for spectroscopy. We're also working with GCMS to see if we can quantify just a simple mass concentration, but I'll tell you, I don't think it's as satisfying as the count, unfortunately, but it's useful for some questions. So with these methods, we can try to probe at these questions a little bit more to try to understand these processes. And so now I want to talk a bit about kind of what really brought me into this field, was trying to understand how does it get into a food web, what happens when it gets there, and how does it impact the animals. So over the years, we've come to understand that there's absolutely no doubt that microplastics are eaten by animals. I've said that earlier. Lots of organisms are eating this material, whether they mistake it for food. We don't quite know, or they smell good because they biofoul with lots of little critters. We also know they can inhale it through their gills, and there's absolutely no doubt that they can excrete it. A lot of microplastics are egested. We are also starting to understand that if it's in the belly of a prey fish and eaten by a predator, that it can transfer through a food web, through trophic transfer. The things we don't quite understand yet that I find really interesting are these questions about whether they bioaccumulate. So we know that they can transfer from the gut of an animal out into the tissue, but what we don't know yet is if they accumulate and increase over time, similar to persistent organic pollutants like PFAS or like PCBs, for example. We also don't know if they bioaccumulate, do they also biomagnify? Do they increase in concentration as they go up a food web? And these are some of the fundamental questions we're trying to understand today. In our lab, we've done this a couple ways. One of the ways we've done this is just to simply see whether translocation occurs in wild-caught fish, and to see whether there's any correlation with the age of the fish, the size of the fish, or their trophic level. So recently, we took 7 different species of fish from Lake Simcoe, which is just north of Lake Ontario, and we looked in their gut and their fillet and their liver for microplastics of quite a large size range. So starting at 63 micron, which I know sounds tiny, but it's kind of big for something that would get out the gut and into the tissue. And we were actually quite surprised to see that, of course we found it in the gut, we weren't surprised to see that, but we were surprised to see the widespread translocation into both the fillet and liver, the orange and purple bars. And all I want you to notice here is how many orange and purple bars there are, and as many non-zeros. So we were quite surprised to see this, but I can tell you we didn't see any correlation with age, we didn't see any correlation with the body size, and we didn't see evidence of increase with trophic levels. But again, we continue to try to ask this question because it's a small sample size, they're from wild-caught fish, et cetera, et cetera. So these are questions I really am trying to understand. Second is, how does it impact the animals? We know that the large debris can impact wildlife. You've all seen images of an animal being entangled. I didn't want to put one of those on the screen today. But here's a picture of a baby sea turtle whose goal when it first hatches is to get from its nest to the ocean. And of course, large amounts of plastic on a debris can cause barriers and make it a little bit harder for that turtle, which can make it easier for predation. We've learned quite a bit about how macro and microplastic can impact wildlife over the years. And we've learned so much that I would say we can now kind of say with confidence that microplastic can impact organisms at pretty much every level of biological organization. So at the molecular level, where you're at the top left corner, you might be looking at gene expression or something that's more physiological. You understand something about the mechanism of toxicity. And then in that lower right-hand corner, you start to understand how might it actually impact an ecosystem. Does it change an assemblage of species? Does it increase or decrease a population, et cetera? And so there's been quite a lot of work done, so much so that we've been able to start to build risk assessments, which I'll talk about in a second. But before I do, I want to say that we're also kind of starting to understand that plastics can sort of take on different types of effects. So there's evidence that microplastics can be a physical stressor, so a physical particle that's being ingested by an organism. So here are 2 of my PhD students, one Kennedy Bucci and the second one Lisa Erdl, who's about to finish her PhD in a couple months. They were both interested in how microplastics can impact fish on the top, and in Lisa's case, chironomids, so little midges that live in freshwater ecosystems. In Kennedy's case, she was really interested in whether or not there was a physical or a chemical effect, and she exposed the fish either to plastic themselves, a high or a low concentration, or to just the leachate of the plastic. And she found significant mortality only in the high plastic treatment where they were actually able to physically interact with it. Similarly, Lisa was really interested in this idea of whether polyester or cotton, whether maybe your cotton t-shirts, so where cotton, how are they in the ocean? So she was interested in both. And then recognizing that for microfibers, they often go through a wastewater treatment plant first. So she said, well, is it the microplastic itself, or is it the actual fiber, the physical material, or this chemical cocktail? And what she found is that the material didn't matter, and it didn't matter if there was chemicals on it, but for the higher plastic treatment, there was a delay in the time to emerge for the chironomid, so a developmental effect. So in this case, these are both physical effects, which a lot of researchers think is a food dilution effect, that if an animal is eating plastic and not eating its food, it's missing out on some of its nutrition. But we've also certainly seen evidence in our lab of a chemical effect. So these are 2 postdocs in the lab, Anna Kolamaheka, who's since moved on to a new job, and Leah Chibwe, who are looking at the chemicals that are leaching from tire dust and how those impact fish. We see weird deformities, we see loss of pigmentation in the fish exposed to the plastic versus those that are not. And we can see here this graph on the bottom just shows that some of these toxicity effects that we see align with some of the chemicals when they're going in the same axes that are leaching from the plastics. And so this is evidence that it's a chemical effect, not a physical effect. We didn't expose them to the particles. So it's complex. And so when you think about building a risk assessment, it's a little tricky to say, do I do it for microplastic in general? Do I do it for specific types? But at the moment, with the information we have, a lot of what's been done is on the quantity of microplastic in general, thinking about that physical food dilution effect or toxicity from small particles translocating out of the gut. So I want to walk you through some of the risk assessments that have been done and sort of show you what some of these thresholds are, so we can kind of think about it in the context of what we know about microplastic concentrations. So the first one I became aware of, well, the two of them I'm going to show back to back, are coming from work that Bart Coleman's has been involved in, doing species sensitivity distribution. So basically what he's doing is he's taking the literature that in the field that's published on microplastic, the toxicity effects. He's pulling them out, saying at what concentration causes an effect, what are these effects? Building a species sensitivity distribution, which tells you the concentration of plastic, which harms, in this case, that orange line, 5% of the species. And what you're seeing here on the blue and black line are the concentrations of microplastics in freshwater ecosystems around the world. And the good news is that most of that plastic is to the left of that line, meaning in most of these ecosystems, we don't think there's a realized risk right now. But some concentrations, unfortunately, are to the right of that line, suggesting that there are some freshwater ecosystems in the environment right now which may be experiencing measurable risk. They did a very similar thing in the ocean, where you can see here the red dots in the ocean are places where you'd have measurable risk today, I guess, with 2010, and how that changes if we continue business as usual, sort of saying we need to do something to turn off the tap, so we don't kind of get to that 2100 or even that 2050 scenario. Now, in the state of California, they recently passed legislation. These were both done out of curiosity and interest. And in the state of California, they passed a law that said you actually have to do this for aquatic ecosystems, as well as human health, which I won't talk about the human health tonight, but I'm happy to answer questions about it later. You have to create thresholds for risk. And so I was part of the working group that did this for the ambient environment. We used very similar methods as above, but updated with new literature. We had strong criteria for QA/QC, meaning we only included studies where if we felt like the experimental design allowed us to answer the questions we were interested in. And we built 4 management thresholds, meaning that for lower thresholds, you might turn on monitoring, and the government needs to start monitoring for microplastics. But at these higher thresholds, you start regulatory measures, or maybe even measures suggesting that you don't want to catch and eat the fish, for example. So we have these 4 thresholds that fall under either a food dilution effect with larger size range of microplastics, or a tissue translocation with a smaller size range. And all I really want you to focus on are these concentrations. And for those of you in this audience that study microplastic, you might think some of these are quite small. And they struck us as being low as well. And especially for me in Lake Ontario, where I do my work, where these concentrations aren't everywhere, but they're not uncommon. And so again, this really says to me that we're starting to understand, there's no longer a doubt in the scientific literature that microplastic or plastic pollution is a problem. We know it's a global issue. There's no longer a doubt that it's interacting with wildlife, and we no longer have a doubt about whether or not it can cause risk. So now the question is, what are we asking as scientists? And I think right now we're at a time where, I apologize for those of us that try to make a living off of research dollars, but I think we no longer need more science in order to know we need to push policy. We just need more science to answer some fundamental questions about how plastics move in the world to help us understand where to push policy, and also, of course, engineering and innovative research and technology to try to solve the problem. So some of the work we're doing now, before I switch into talking a bit about the policy, is trying to understand some of these processes. And so I have, I'm really privileged, I think, to work at the Experimental Lakes area, which is in southwestern Ontario, or northwestern Ontario, sorry. It's a plot of land that's sort of been zoned off for research. There's 50 lakes in the area, some of which are long-term ecological research stations for monitoring, and some of which you can manipulate. Some famous work has been done in this area, for example, with acid rain. Acid rain was discovered, I don't remember what years, was it in the 70s? They started doing work at the Experimental Lakes area, actually changing the pH of a lake, showing how it impacts aquatic ecosystems. Yes, that one lake took one for the team, but that lake helped push the acid rain treaty, which was signed in 1982 by both the United States and Canada. So we are gearing up to do work here on microplastics. Here you can see us dosing a big limnocorral to start to understand the fate in an ecosystem, the concentration that matters, and then eventually we'll get to a whole lake experiment where we can really understand processes about the fate of the plastic, the transformation, and how it really moves through and affects the food web. Okay, so that's kind of the science. And now I want to flip to spending the last 15 minutes talking about the policy. So how did we get here, and what are we doing about it, and what should we do about it? So I kind of like to start with this image, and if you've been to a talk on plastic pollution, you may be sick of this image, but this is the cover of Life magazine just after World War II, when the plastic industry was really starting to boom. And it was this idea that with plastics, we could have a more convenient life. And when you read past the headline here, it's all about how this housewife can have like 200 people over for dinner, and at the end of this dinner, she doesn't have to wash the dishes, she simply gets to throw them away. And it was sort of the beginning of this single-use throwaway society. At this time, we maybe were producing 500,000 tons of plastic per year. Today, we produce about 400 million tons of plastic per year, and about half of that are these single-use convenience items. I think the biggest issue that we have today is how we manage this material and whether or not we value it. We have a very linear economy, meaning most of the plastic that's ever been produced, so of the 8,300 million metric tons that went into our system through to 2015, less than 10% of that has been recycled. About 10% of that has been incinerated, some of it for energy, but some of it not cleanly. And most of it, of course some is still in use, but most of it is discarded, either into a landfill, which can kind of go from like a dump to an engineered landfill, or out into the environment. And I told you earlier that we think 8 million metric tons of plastic goes into the ocean. Well, that number has been updated, and now we predict that about 24 million metric tons of plastic goes into aquatic ecosystems writ large, so the oceans as well as freshwater. The number before included some of the plastic up in the rivers, assuming it would go into the ocean. This number goes a little bit inland. So it's not an apples to apples comparison, but it's quite a bit larger. And I want to remind you that in 2015, the world sort of decided that 8 million metric tons was too much. So we've gone above that. What's good is that we're starting to see action at every level of government, and this includes all the way up to the United Nations and other international work, which is motivated by our ocean conferences, the Sustainable Development Goals, and talk about an international agreement. So for me, when I kind of think about the change, I sort of lump the types of things we can do into 3 bins, pun intended, but these bins are you either reduce your plastic waste, so that includes banning some of those single-use items, reducing the amount of waste that we put into the system, which actually can also include building that circular economy. So I'm including recycling in here too, as long as it doesn't become waste that we never use again. You can also increase waste management, so simply collect it. We do this curbside here, then take it to some engineered closed system where it's managed as waste. And then finally, you can clean it up either manually with your hands or through trash capture devices or other ways. And so when we were figuring out that 24 million metric tons estimate, our real goal, we didn't care so much how much we have now, but we needed a baseline. What we really wanted to understand is what happens if we do nothing? How will that number increase, that yellow line, in a business as usual scenario? How much work do we have? What if we did everything we promised? That's the blue line, so I'll show you what that looks like. And how much work do we have to do to get below that 8 million metric tons that the world decided was not okay? We do break this up by income levels within countries because there's different contexts within different countries in terms of their current waste management strategies, their current plastic production and consumption, et cetera. So what I'm going to show you is kind of what these different scenarios are. So in a business as usual scenario, this means we can keep using the amount of plastic and producing the amount of waste that we do. This is really what I want you to focus on, is how much waste is managed. In low-income countries, the average is 6%, and in high-income countries where we are, the average is 63%. But in the United States and Canada, that number is actually about 99%, but it does not account for the waste we ship to other countries, which may or may not be managed. So that is definitely something, a kind of a caveat within this model. So business as usual, we obviously don't want. What about that blue line? That's us trying to add up all of those different commitments and policies that are being introduced today on the global stage, some already enacted and several not yet. So that looks like about a 0 to 10% reduction per person in the amount of plastic that we use. And for us, it would only be 10% in the high-income countries, so the top end, but 10% doesn't sound so bad. For waste management, you have to increase from 6 to 30% or 63 to 90%, and we have to clean up 10% of annual plastic emissions. That's actually quite a bit of work, all three of those categories, but it doesn't get us to a place we want to be. We don't want to be at the blue line. We want to be at the purple line or lower. So how hard do we have to work? And in this field, when I go to policy conferences, I hear people say the only solution is to reduce plastic waste and ban. The only solution, hardly anyone says the only solution is cleanup. The only solution is waste management. You hear that a lot from industry. So how hard do we have to work if we just pick one? Because I don't think there's one silver bullet, but what if we just do one? So if we just reduce waste, we have to reduce 85% of the amount of waste that we use per capita. So that's me asking you, audit your waste this week for fun, and then see if you can reduce by 85%. Quite a lofty goal. The second one is increasing waste management to more than 99% everywhere. That is a lot of work in certain parts of this world and a lot of money, and you want to do this quick. Remember, this is by 2030. And the third one, which nobody agrees we should only clean up, is increasing our cleanup to 30 to 77.4 million tons of plastic per year, which is insane. So we cannot lift the barbell alone, and I think we have to tug on all of these solutions at the same time and quickly. So what if we just kind of pull on each lever equally until we get below that 8 million metric tons? So here, we need to reduce our amount of plastic waste by 25 to 40%, 40% here at home. We have to increase waste management from 6 to 60% in low-income economies, and 63 to 99 in high income. And we still have to clean up a lot of plastic. So how are we going to do that? How are we going to roll this big, heavy boulder up the hill? And the reality is I think we can. I absolutely think we can, but we need to recognize the size of the issue, the complexity of the issue, and start to really make systemic change. So we sort of made a call for the things we think we need to do. We need to reduce or eliminate the use of unnecessary plastics. We need to set global limits for virgin plastic production by de-incentivizing fossil fuels. We are currently making virgin plastic cheaper, and incentivize recycled plastic, so that is what's cheaper. Globally harmonized standards for recyclability and recovery so we can actually build a circular economy. Right now, the system set in place is not really ready for it. We need to innovate and scale up some of these recycling technologies. I had some great conversations today with the students about chemical recycling and other technologies that may or may not work. And then we need to continue to prioritize cleanup until we don't need it anymore. And this work has to be done at all levels of government and across all sectors. So the government, the scientists, the industry, we all need to be on board working together in order to truly fundamentally change the system. And so one of my favorite quotes comes from Senator Gaylord Nelson, who was the founder of Earth Day, which on this day he said, "Are we able to meet the challenge?" And he truly believed the answer was yes. And the question was really, are we willing? We were willing for DDT. We may argue how willing are we for climate change, and we'll see how willing we are for the issue of plastic pollution. But there are definitely some stories that give me a lot of hope and some policies that are being enacted around the world that I'm happy about. So the UN is going to be continuing to negotiate an international agreement on plastic pollution in February that may, I hope, look a lot like the Paris Agreement for climate change. In the United States, at the federal level, we were one of the first countries to have a really solid ban on microbeads, and it makes a difference. We see much less of them, at least in our samples at home. The Save Our Seas Act is a bipartisan act that passed, I believe, under the Trump era. There were two of them. Maybe one was Trump and one was before. But they're bipartisan. They brought in funding for research. They brought in funding for greater understanding. And they've sort of led to this Break Free from Plastic Act, which has a lot of language in it that is more like some of these policies that we need that I mentioned earlier, like de-incentivizing virgin plastic, having strict laws for, or strict standards for recycling, as well as washing machine filters to stop microfibers, et cetera. The state of California, I think, is also leading the way, starting with many, many different types of legislation. I won't read them all. But some of the ones that are interesting is this truth in recycling, which is to basically try to help to force companies to make recycling more transparent, not to put those chasing arrows with the number on it in everything. It has to truly be recyclable where you live with information for how to recycle it. Filters on washing machines, I think, are really important, as well as some of these risk assessments I mentioned earlier. And the other thing that gives me hope, and the last thing I want to focus on, is some of the local work we do at home. I didn't become an academic because I loved research, even though I do truly love research and I wouldn't want to leave tomorrow. But I really got into science because I truly, truly believe that scientific facts are what should drive and inform policy. And I wanted to help build that body of knowledge. But then I also want to make sure that body of knowledge gets out into the world. So we've created kind of a community outreach group within our lab called the U of T Trash Team. And it's how we try to work locally to sort of inform a global solution. And our goal is really to increase waste literacy in our community while reducing plastic pollution in other ecosystems. So what we do is we do community outreach. We go out, we do cleanups in the city, talk to the public, try to get involved with the local community groups. We have educational programs where we bring lesson plans into 5th grade classrooms that our students have created, so it's a bit peer-to-peer. So a scientist for them gets to look like one of our students instead of someone a bit older like me. And then we have solutions-based research projects where we do incredibly applied scientific projects that are really geared towards helping inform really kind of local, tangible solutions. So some examples of those are our pollution prevention projects where we directly work with different sources. So we work on pre-production pellets, microfibers, looking at filters on washing machines. We have a project right now on single-use foodware, trying to help inform policy in the city of Toronto. We do a home waste audit that I invite you all to join in January, where we literally ask the public to audit their waste at home, learn a bit more about your local waste stream, and try to reduce the amount of waste you produce and see how tough it is to really change those habits, but also to start changing those habits. Our Fighting Floatables project is locally in our waterfront, trapping trash with sea bins, tagging trash with GPS taggers to understand how it moves around, as well as trying to understand basically just visually looking at the trash around the harbor to see what is there, where does it come from, and how can it inform some of these sources. We got really interested in trapping trash through trash wheels and sea bins and gutter bins and all these types of machines, because remember in that previous slide, I said we have a lot of cleanup to do. And so I'm actually really inspired by some of these trash traps, even though I hope we put them out of business because we don't need them anymore. So we recently launched the International Trash Trap Network with the Ocean Conservancy. We've created protocols for how you quantify and characterize the waste in your bins. And we work with Ocean Conservancy to put them into an app under the International Coastal Cleanup so that people can monitor their local impact and then put it into our app to be able to also help us quantify our global impact. So the work that we've done locally has informed different types of policies, including new locations for trash traps around the Toronto waterfront, this idea for the International Trash Trap Network, which anyone can join, and then we are working on policies. So right now we're working with the Ontario government and the industry to try to make zero pellet loss a regulation, so industries will have to put traps around their companies so they can't let their pellets go down the drain. We're working on, we find a lot of styrofoam in our bins, and it does not look like the kind we're banning in foodware, and we find that it has bromines in it, flame retardant, so it's coming from construction. So we're trying to work with the Ministry of the Environment to figure out what do you do about that one. We're not going to stop making buildings, and they're probably still going to use foam, so how do you stop it from getting out into the environment? Our washing machine filter project has been really successful, and we now have policy written in Ontario for putting washing machine filters on washing machines. It's also informed policy in California as well as in France. And then single-use plastics is a new project for us. Right now there's voluntary regulation, totally voluntary in Toronto, that says, restaurants, we encourage you to allow people to bring refillable mugs or bring refillable Tupperware. What we're hoping is that eventually restaurants have to allow that. Doesn't mean they can't have single use, it just means they have to allow you to bring in your own mug. A little tricky under COVID, but it's starting to happen again in Toronto. So we're trying to do some research to see what are the barriers to that and how can we bring restaurants on board. And so with that, I think I will end there. I think we all share a shared goal. I think we can all work on this issue from every level, which includes starting with us. So I'm excited about that, and I'd love to be able to have a conversation with you. I'm happy to answer any questions or hear about the work you're doing. Thank you. Thank you.
So our portable mics are broken, but I have a mic here. Someone, there we go. There's a question at the back.
Thanks so much, Dr. Rochman. Very illuminating presentation. My question is somewhat inspired by the negotiations that are happening or that took place in COP21 that we saw. And it's sort of a similar question with regard to plastics pollution. And I was wondering to what extent, because the assignation of responsibility is a very difficult thing in the case of plastics pollution in the oceans and in water streams, to what extent have conversations around justice, global justice on this issue unfolded?
I have to be honest, I'm having a really hard time hearing you. I think it's the combination of the mask and the tiny microphone.
Okay.
Sorry.
So
Should I
maybe
repeat it?
Yeah,
Okay.
nice and loudly. Yeah.
I'm
Remove
sorry.
my mask. That's all right.
That's a lot better. Okay.
Thanks so much for your talk. My question had to do with COP21 and the negotiations, or similar, right?
Yeah.
And my question is that it's very difficult to assign responsibility in the case of plastics pollution, right?
Yes.
So to what extent have conversations about global justice entered the picture when we are talking about policy and when we are talking about solutions? Thanks.
Yes, great question. And thank you. I'm sorry, I could hear you so much better that second time. Yeah, it's really important. And that's actually one of the reasons why in our model we had differences between high-income countries and low-income countries and everything in between. Because the plastic issue isn't the same around the world, right? There are places around the world where we have much better waste management systems because our governments have the money for it or we have strict regulation around it. There's other places around the world where they simply don't have the resources to be able to have that waste management, or they just have different waste management strategies, a more informal sector, but the amount of plastic that's being brought into those places is increasing a lot, and that includes single-use plastics. So if we are to build, right, an international agreement around plastic, how can we make sure that all economies have the resources that they need to act? And so I personally think we should have a global fund that maybe comes from a plastic tax, which is in the break-free bill, and that funding can go to help fund other countries in order to be able to get better waste management, which we all deserve, as well as the shipping of plastic waste. So the Basel Convention actually just changed the shipping of plastic waste. It used to be that countries around the world shipped a lot of their waste out and they'd call it managed or recycled. China said no more. Other countries still take it. Through Basel, it now has to be more transparent, and hopefully we stop shipping our waste around the world. So it's a great question. It is being thought about, and we'll see how well it comes to the fore as we build the agreement.
I have a question while other people are thinking. That 6% to 60% for low-income countries, that's a pretty incredible increase by 2030. I know that you talked about a tax there, perhaps sort of making that, have you ever thought about the economic side of making that, some of the cleanup also is a big number. How about the economics of doing this?
Yeah, that's a really good question. So there have been some, so I work really closely with Ocean Conservancy, and they have a group called the Trash Free Seas Alliance, which brings together industry and government and NGOs to work together on the issue. I'd say the majority of the time they spent in that room is talking about finance. How are you going to finance waste management around the world? How are you going to finance increased recycling facilities and to scale that up, and then cleanup? Some of that money is going to have to come from industry, and there's also been some groups working on actually finance options for it. I obviously don't work on finance, although both my parents are accountants. But yeah, it's tricky. How do you get from 6 to 60% in 9 years, 8 years? It's a lot of work.
Hi, thank you so much for your wonderful talk. So you mentioned about the price of virgin plastic production kind of decreasing as we're moving forward, which is obviously not a great incentive when we're trying to hopefully incentivize people to not use plastic, but if the price is getting cheaper, it's kind of a worst case scenario. Is there concern that kind of this, kind of going off of, again, the COP26, was it COP26 we just had?
26.
Glasgow. And all of this kind of investment in sustainable infrastructure, particularly clean energy, that those crude oil production companies are going to shift their focus to selling now more plastic because that's where they can take their product.
Is there concern for that? Is that what you said?
Is that something that people are kind of talking about?
Yeah, no, there definitely is. And I think there's evidence of it happening with plants being built. Ohio, Alberta, there's places where you're seeing more plastic production facilities in the works right now. Which is why I do think in some countries, Canada introduced potentially a cap on virgin plastic materials. And I don't know whether, that's a tricky one. Caps have been really hard on oil. And so, but absolutely, like we have to de-incentivize fossil fuels and de-incentivize virgin plastic production because we can't build a circular economy if virgin plastics are cheaper. It just probably won't work.
You know, I was thinking about some of the other talks we've had in the series, and I was wondering, so it seems that plastic is ubiquitous in all, say, wild fish that might be caught. How is it for aquaculture? Is it possible to be able to separate it? And, you know, is it less, obvious that if you eat fish grown through an aquaculture system that you're going to have less plastic in it?
Mm-hmm. Yeah, there's been some work done. So I don't know what you learned when it was on fisheries, but certainly there's definitely a push, I think, for aquaculture in terms of how to keep a sustainable seafood economy. And then for aquaculture to be done in a certain way, of course, so it maintains sustainability. For plastic pollution, of course, there's plastic gear used in aquaculture, but there hasn't been a ton of evidence that aquaculture has been a huge source of plastic pollution. Some, but I think you're asking actually, like, could you have cleaner fish by using aquaculture? That's a good question. I don't know. A lot of because often it's done in the ocean, but if the aquaculture is done on land, then I would suspect yes. But I don't think seafood is probably our largest source of microplastics for humans. I think for us, it's probably more, it sounds really doom and gloom to say that, but I think with the numbers, it's more the plastic that's in the dust as well as what's in drinking water. And so I don't think the seafood that we eat is kind of something that we need to worry about amongst some of those other sources.
That was great. Do you have any metrics on how much microplastics are produced when producing single-use plastics?
How much microplastics is produced from single-use plastic?
No, in the production, just making them.
I don't know if I understand the question, sorry.
In the production of single-use plastics, do you make a lot of microplastics?
Oh, yeah, good question. Actually, I have a colleague that is obsessed with that question and would love the way you worded it. So when we produce plastic, so it's literally made from oil, and it goes to make these little pre-production pellets, which are then shipped to the next person who usually melts it down and molds it into those single-use items. And so when they do, some of those pellets are lost, and then as they mold them, there's scrap produced in the process. So there's lots of microplastics within these. If you've ever been to, I would encourage you to go try to visit one, actually. It's interesting to see. That's made in the process. And if the industry has grates on their drains and is diligent about sweeping and make sure that they have backstops and air filtration and all of that, they shouldn't be releasing that microplastic. They should be cleaning it up. And in fact, it's their product. They could melt it and use it again. But unfortunately, a lot of it, I don't know about a lot of it, some of it is lost. And we see it in our trash traps at home because we have quite a few industries upstream. So that those regulations, when I say releasing or reducing, regulating pellet loss, it actually includes exactly what you're talking about. And my colleague Paul gets so frustrated, he works for the government, that we keep calling him pellets because he's like, well, what about the scrap that's produced when we were actually producing the product? So all connected. Thank you.
Thank you for that talk. It was really great, Chelsea. And I know that you are on 1,000 different other panels too, and I know that you also work with human health. Can you give us an update on where we are in terms of microplastic effects or micro and or nanoplastic effects on human health?
Yeah, kind of an update on what we understand about human health. Yeah, so with this California working group, we were asked to actually the group was formed more because of prioritizing the human health question. So California wanted us to define microplastics to say, in drinking water, what size do we care about, and what is microplastic in legislation, because words matter. 2, we had to figure out how we're going to measure it. So what size can we measure? And as you know, Kay, right, it's incredibly hard to measure the really small stuff, but we decided the small stuff is probably what really matters for human health when you think about translocation in the literature. So we're really interested in kind of that 20 micron and smaller, even though we'll measure it all. And then we looked at the health, and we were asked to come up with a threshold. And I wasn't a big part of that working group, but I certainly got to watch its progression and hear about where they were. It was led by Scott Coffin. Basically, what they did is they came up with a framework for risk. And actually, it was really neat. They came up with a framework that included all of the different sources of microplastics we're exposed to. So that's where, when you ask that question, I can say, put it into context. So that includes how much we're exposed to from food, from water, from seafood, from the dust that we breathe. And so if you're creating a risk assessment, you think about the contamination from all those sources and then how much matters in drinking water, given that you're already exposed. And I think that comes from OWIHA work, or it was pulled from something from EPA. And then they wanted to come up with the threshold, and that's where they struggled. I think there was about 15 papers that they had that gave them good information about how microplastics impact human health. A lot of it's either in vitro cell work or mammal work, so mammalian models. A lot of the work that's been done is on like small polystyrene pellets that you can buy from Fisher Scientific, which may not be like all of the plastic we're exposed to. But a lot of the effects were around endocrine disruption, so sperm motility or the amount of sperm within the organism. So they didn't come up with a threshold that they felt like they could give to California to say, here it is, but they came up with a number, and I can't remember off the top of my head what it is. But basically what they said is we need more research. And you know, I wish I had more information on how it impacts human health, but I can tell you that 10 years ago, I would get calls about how it impacts human health, and I was like, you know what, I'm an ecologist, I have no idea. They don't call me anymore, which means they're calling people who are experts that are actually studying it, which is great. So that field is growing, but it's still just like a handful of literature, which is kind of where we were with ecotoxicology a decade ago. So I feel like in a couple years, you'll have a better answer. Do you agree? Yeah. 5 years? Yeah.
So I'll hand it off to, yes, Andy. I was going to make one comment and say, it looks like we have a lot of cleanup to do, and I'm thinking Rhode Island needs to form our own trash team and challenge you to an Olympics, a little trash Olympics.
Okay.
So we'll make a plan for that.
Am I going to finish it? Yeah. Okay, everyone. So thank you very much for coming tonight. And the next event is 30th of November. We're at the Plastic Pollution Panel. Same time, same place, 7 p.m., Tuesday, Edwards Hall. Okay? 30th of November, we have Cara Lavender Law that Chelsea has mentioned several times with a bit of a name dropping there. So we have a major person coming. If you haven't heard of Cara Lavender Law, you need to read some more about marine plastics. A major name. So Chelsea, thank you so much for your presentation tonight, and a round of applause, please.
Thank you, everyone.
And get home safe, everyone. Thank you.